Welcome to today's webinar. The topic today is news in Rfem 6 and Rstab 9. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the content of the website, the German and English webinars, newsletters, and so on. I will be the moderator today, and I will also present this webinar. I will give an overview what we integrated in the add-ons, or we implemented new features, new add-ons, and so on in approximately the last year. In short overview, the webinar will take about 1 hour. My colleague Jürgen Theilmann will support me, but he can introduce himself.
Yes, thank you, Andreas. Yes, my name is Jürgen Theilmann. I've been working for Dlubal support for maybe 2.5 years now, and I'm in customer support where I answer your questions via email, chat, telephone, whatever. And today I will just do that, answer your questions regarding the topics of today's webinar, while Andreas will be presenting. Yeah, that's all from my side. Back to Andreas.
Okay, maybe in additional information to me, I've been working for the company Dlubal Software for 13 years. Okay, then we can switch off the webcams that the attendees can see the full screen. I say some words, at least for the attendees who participate the first time. You can see a control panel on the right side of your screen. You can show that with that arrow, and then you can enter the question here. And then you will get an answer from Jürgen. If you don't get an answer because there are too many, he's alone, then you will get an email in the next days. The other way is to watch the entire webinar and email your questions to info@dlubal.com. Okay, then I come to the agenda today. First point is new features in Rfem 6 and Rstab 9. I introduce some features. I said it already, what we implemented in the about the last year. Then new features implemented in the add-ons and standalone programs. The first point is for features that are directly in the main program, and those features are in the add-ons and standalone programs. Then I introduce new add-ons, and the last point is prospects. I give an overview what we schedule to implement in the next time. The main presentation is in PowerPoint, but I will also introduce some features in the program, directly in the program, but only for features that are in Rfem 6. I think those are the features that the most of you are interested in. Okay, then I come to the first point, new features in Rfem 6 and Rstab 9. First feature, support force transfer from our model. We implemented a load wizard for that, and you can transfer reaction forces as nodal or line loads from one to the other model. I will show that in the program, but I skip or I turn already to the next feature, new interfaces. We implemented the T-class structures interface, bidirectional interface, then the step interface, then RSF for Allplan, and SVG. Those are vector graphics. So then I turn to the program and I introduce the first feature, the load wizard for the support force transfer. So I prepared those two models. that's a small shelter that should stand on that roof here. And the 4 columns should stand on these 4 points. I select only the roofed slab that we get a better overview. So that's quite better. So, and now I turn to Insert in the menu, Insert, Load Wizards, where you can see all the load wizards, the member loads wizard, and snow load and wind load wizards, and that's the new wizard, or quite new wizard, and I open it. Yeah, important information, all the models that when you want to transfer a load from one to the other model, the models must be placed in one folder in the Dlubal Center. So I have several models in one folder. Those are the models for today, and that's number 1, and the shelter is correct for the building. Then that's why we can leave that. I turn to the next menu, Objects. You can select the support node or supported nodes in that model, in the shelter model. I can select all or only different nodes. When not all, for example, in this example, not all columns should stand on the next model. Okay, I select all. We have only nodal loads, no line loads, but it would be the same workflow. If you have, for example, under those line supports a member in this model, then you can check that to create member loads if a member loads on the selected line. Then we turn to loading. You can apply the line loads as uniform load or varying load. That depends on you. Then you can choose the connection type manually or automatically. Manually, you can select the different load cases, 2 loading, and so on. I've in the shelter model only 1 load case. That's why I can do that automatically. But you can define in this table all the different load cases. Load case 1 to load case 1, load case 2 to load case 2, or something like that, if you want. Then you have to select the direction. I select on the 3 directions. You can also transfer moments if you have a rigid nodal support, for example. Okay, that's all. So, I forget something. I have to select the nodes in the building model. So I select them in the right order. Okay, now all is fine, and can press OK. And you see, the loads, but with a question mark, they are not calculated yet. I have to start the transfer by calculating it. Now the program connects both models and transfer the loads from one load case to the new load case. And you can see, I can compare the support reactions, and in the opposite direction acts the nodal load. 3.7 on this side, and on this side 1.39. So, and when you change, for example, the load here in the shelter model, I enter 2 kilonewton per square meter. Okay, then I calculate the load case again. Then I save it. So then where comes the question? This action deleted all results. Yeah? It means the results in the building model. Yes, okay. And now I transfer the loads again. So let's compare the reactions and loads. 11.31, yeah, and 3.92. And also the horizontal loads were transferred correctly. Okay, that's all to this feature. I would like to show you the interfaces. Export, yeah, for example, the ASF interface. Then to Allplan, yeah, SVG, import, step, and so on, and the other interfaces that are already implemented. And then there are also the direct interfaces to Tekla structures and Revit. Yeah, you need to install the other application, and then there's an additional menu here. You can transfer models and so on. Okay, I turn back to the PowerPoint. The next slide. Building grid is a new feature. You can optional add dimensions. I show that in the program. So I close these two models. So simple model. And I go to Insert, Guide Objects, and Building Grids. So that's the menu. Yeah, you need to enter the dimensions of the grid. Usually they are known with a space between the numbers. Right. And 0 and -3. Okay. And you can already show that in the preview. When I press this button, I can see if it's correct. You can enter here numbers also if you want, rows and axes. I leave them as they are. You can log it in the graphic. You can add grid points that you can snap such cross points here. I hope we can see that. Then those are the grid lines. Those are the grid points. Labels. You can add dimensions and so on. So, and if you want to enlarge the lines here, you can select those entries here. So, and another 2 meters. That looks quite good. Okay, and that's the line grid. I think quite good feature. So then also use the layout mesh for solids. That's for the geometrical analysis. That is what I have in my mind. For example, if you have a slab, a foundation slab with a mesh size, for example, 0.5 meter, and you have a very depth soil model, for example, 10 meters high, and then you can define a larger mesh, for example, 1 meter. That's the new feature. Yeah, but you can choose it also for other solids. Oh, that was too far. Sorry. So that's the new page. Then it's possible to do a supervision of several geometric imperfection cases. We showed that already in a webinar about buckling analysis. That's, for example, for the Gemini A analysis. That's important to have that for such buckling analysis. Then the new feature is blocks with reference to block specification. Imagine you have several similar blocks, and you can define a mother blocks. For example, you have more than one truss girders in your model, and when you change something in the mother block, it will be transferred to the child blocks. For example, the height of the truss girder. Okay, then next page, optimization of cross sections. That's available in the design add-ons like steel, timber, or aluminium design. And you can optimize for a section of series or for the width or depth and so on. I would like to show that on such a parameterized cross section. I turn to the program. So this model is already designed. Let's go to the timber design. Increase the table. We get a lot of results here. I turn to the input data and to the sections. You can see the 3 sections of this model and the different utilizations. This section has a utilization of 64%. Those are the columns and this upper beams here. And I would like to optimize it. So how to do that? I go to this table here, and I open the drop-down menu, and I select Optimize Current Row. So, and I would like to optimize the width. We start with 100 millimeters, and maximum should be 180. That's the current height. The current width, I mean. Then the step should be 10 millimeters. And now you can see in this table the available cross sections. And the program should optimize this cross section. Okay. We have to run the timber design again. So we turn back to the input data to have a better overview. Now we have got a utilization of 99%. The new or the optimized cross section has a width of 110 millimeters, but in the global model there is still the old cross section. That's why we need to do a right click here and use the optimized sections in the model. And then we have to calculate all again. Also the load combinations in the global model. The optimized cross-section has a not so less height, less weight, and now it considers the right cross-section. Okay, let's see what we have got. Okay, now we've got the utilization of 96.5%. Right? Yeah, for example, for steel models or for steel design, you can optimize in one row, or you can define a favorite list, for example, that the program optimizes for AGA or IPE sections in one step. Yeah. Okay, I turn back to the PowerPoint. New feature is the calculation diagram type, 2D story. It's the creation of result diagrams via building axis. It's for example, necessary for the seismic, to visualize the seismic force over the building high. That's one example. Then the friction properties for line releases. Let's take a look at this model here. For example, you have a concrete slab on a steel beam, and you would like to consider the friction, then you can define such line releases. Then the ponding load type. You can consider rainfalls in the ponding, and the program calculates the ponding size and transfer them to vertical loads. And that's usually necessary for membrane roofs or almost horizontal membrane roofs. I use this model in the program. Just a moment, ponding. So now such a small pavilion, for example, where the load case pre-stress, then wind, and through the wind you get some such a deformation. Then the first load case of the pond one, I double click on it, and you can see the load type here, ponding. You can select the amount of precipitation and then the specific weight, or in this case water, 10 kilonewton per cubic meter, and an amount of precipitation of 1 millimeter per square meter. Okay. Then the next load case has 2 millimeters per square meter, and the next load case where we defined no amount of precipitation. It should rain until the pond is full. Okay. And you can see in this load cases there are no deformation, only in the combination with the wind. You have got the deformation from the wind, and on this place where can collect water. So let's take a look on the combination number 2 with wind and pond 1. And let's take a look in the navigator results, shape, and the water depth or the water level, doesn't matter. I go to the wireframe model, and you can see that's the point for this load case, 1 millimeter per square meter, then 2 millimeter per square meter, yeah, and full. And now the pond is full, and yeah, the rest of water flows over the edge. And you can also select the water depth, which are on the panel. You can see when it's full, the water depth is about 60 millimeters. Then for this combination, about 40 millimeters. And for this one, about 30 millimeters. Okay, then I turn back to the PowerPoint. Next feature, Spring member type. Yeah, you can define a spring constant, for example, yeah, and usually that's force divided by displacement. Then the generating combination with more than one initial state. You can consider different initial states for a target combination. For example, for a form finding process with varying imperfections. Then we implemented the scaffolding hinge. If you want to design scaffoldings, you can use this special hinge. Then, I think a very valuable new feature, the cross-section modification using Rsection. You transfer a cross-section to Rsection, and you can modify it there and import it again to Rfem. I would like to show that on an example. That's the last model for today. So I go to the sections. I would like to change this cross section. For example, I do a right click on it, edit. So, and that's the new button, the transfer to Rsection. So I press it, Rsection opens, and the cross section, you can see the message there, Rfem mode. So to modify this cross section, I have to, just a moment, section, I have to explode it by right click on the section, explode. Then I modify it a little bit. Now I move that in this direction, minus 30 millimeters, okay. And I add a new element, a line with a thickness, a small sheet. So that's the start point. Then I enter the new coordinates, minus 40, for example. Thickness, okay, 10 millimeters, that's okay. I apply that. So, and then I would like to transfer that back to Rfem. I have to press return, save and return. So now we are back in Rfem, and you can see the modified cross section. And now you can use it for the forward calculation. Let's take a look on one of these members. Now you can see the modified cross section. Okay, let's turn back to Rfem, to the PowerPoint slide. So new features are also the cloud calculation. Yeah, maybe you know that when you have a larger model and it calculates a longer time, and yeah, the power of your local computer is then less when you work in other programs, and yeah, then you can use the cloud calculation. I turn back to the program to show it. Under calculate, you can find calculate in cloud. And yeah, you can choose the machine type automatically or Microsoft Azure. And you can select one of these machines. But you have to buy credits for the cloud calculation. And this link leads to the web shop. And yeah, in the extranet you can see the calculation tasks of your company or your calculation tasks. I think a very good feature of when you have to design larger models. Not for models that calculate 1 minute or so, but for larger models. Then a new feature are the info bubbles for line supports. You can activate it in the navigator results. Now, for example, you can see then in the bubble the description, sum, mean value, and so on. Yeah, then the next new features are valid for the timber constructions, but you have to define it in Rfem directly. That's why I've added here to the new features in Rfem 6 and Rstab 9. The shear force reduction. You can reduce the shear force with that new feature to a optimized design with a smaller shear force or reduced shear force. Then there are curved section distributions, mainly for the timber, for timber constructions, curved, pitched cambered beams, fish beams, those four beams. Then a new feature is the transversal compression stiffening elements for design supports. When you can support it with screws here. Oh, sorry, that was already the next slide. And you can design shear resistance is checked in plan of screw tip, and also a bolt analysis for pressing in and buckling. Then we turn to the next point, new features and add-ons and standalone programs. I continue with the timber design add-ons. You can consider the crack factor, KCR, for surfaces. Then the design of LVL members is possible according to Eurocode 5, where 4 manufacturers are available: Pollmeyer, Metze, Styco, and Stora Enso. Then more features in the timber design add-ons are for the Swiss standard, the design of cross-section of method 1 type. Those cross-section here. We implemented the Australian standard, and the design of CLT panels is not only available for the Eurocode, but also for the Swiss standard and US and Canadian standard. Then the multi-layer surfaces add-on. where is a library of manufacturer for CLT panels, for example, Binderholz, derricks, and so on. Yeah, and there are also more compositions for the USA and Canada. Then, yeah, a lot of new features in the concrete design add-on, the design of our section, cross-section. Yeah, you can define a cross-section in R section, yeah, with the longitudinal reinforcement and also the shear reinforcement. Then you can transfer it to Rfem or Rstab and design it there. We already showed it in the webinar. Yeah, just click on that link here. You can download the PowerPoint slides in PDF format from our website. At the end of my presentation, I show you where you can find those slides and the recording and so on, and also the models. Then new is the cross-tie reinforcement. Yeah, such additional cross ties on 3 rebars of longitudinal reinforcement. You can see that here in this image. Yeah, and you can also consider them in the design. So then it's possible to, as the design of fiber reinforced concrete is possible. We already showed that in a webinar. Yeah, just click for more information on that link or watch the webinar. Then a fatigue design is possible, and we implemented 2 different methods here in the program or in the add-on. Then the seismic design according Eurocode 8 is now possible. We showed it also in a special webinar. Yeah, if you would like to get more information, just watch the webinar. I added the link here. Then a simplified fire resistance is now possible according to Eurocode 2 for columns and beams. So then a new feature is the layout of surface reinforcement. Now you can select what you want to lay out or what the program should lay out, the rebar diameter or the rebar spacing. Yeah, often wished feature, and we implemented it. So more features are the multiple editing of member reinforcement. You can see that in the image here. You can define the reinforcement for more than 1 member. Then use the required reinforcement for serviceability limit state, and you can print graphics via print templates now. So then we turn to the steel design add-on. It's now possible to design code form sections according these standards here. Eurocode, USA, Canada are the countries. And yeah, we showed it in the webinar, at least for the Eurocode. Yeah, if you want to watch that, just click on that link. And yeah, for the normal steel, we implemented new standards, the Switzerland standard, then for Brazil, and the American seismic design is now available. Then the add-on structure stability, the modal relevance factor is now available. Yeah, it's quite useful if you want to use the buckling length for a stability analysis or for your design. You can use that modal relevance factor. You can see if it is a local or global mode shape. For a better description, you can click on that link and you get more information how that works. Then there are a lot of new features in the steer joints add-on. The steer joints, it's a steer joint design for build-up and thin-walled cross sections, according to Eurocode and the American standard. Then there are new components: the connection plate, member editor, inserted member. Now you can, for example, insert a member that won't be considered in the global program. Then an auxiliary solid to cut something out. Then a cap plate, for example, when you want to define a cap plate on the top of a column, then you can use that. And it takes you only not many steps. Then the welds are designed now plastically. It's more effective than before. Then you can calculate the initial stiffness for the normal force and the moments, and the multiple selection is possible. And then you can find it in the table. So then the classification, you can then find in the table if the connection or the joint is hinged, semi-rigid or rigid. Then you can consider preloaded bolts. On all components, you can define if you want to consider the preload. And then it will be considered in the stress strain analysis and the stiffness analysis. Then now the circular hollow sections are available with a weld joint. You can see the connection of the sections, of one section to another section, or the to planar structure components. You can see the weld here, and also there's a weld. Okay, then building model add-on. The floor analysis of detached 2D structures is available. You can calculate the global model, and then you can calculate local the 2D can do a 2D calculation of individual floors. For example, in that image here, you can see the roof slab. Then the load transfer only story type, without any stiffness, and it collects the loads and transfer them to the next element. Then there are different modeling tools for building models, vertical line, columns, and so on. And more features are the shear walls, defining of deep beams, and the building story generator. The building story generator, you can do with one click, or can create with one click all the building stories. When you have got such a model, and with one click, all building stories are defined. So then add-ons for the dynamic analysis, the automatic operation to reach a specific effective model mass factor. It's a often wished feature from our customers. The program determines the count of eigenvalues until the 90%, for example, of effective model mass is reached. You don't need to do that manually. anymore. Then the sensitivity coefficient is new. It figures for interpreting sensitivity with regard to stability effects for building models. So then our section, the plastic resistance with variation of shear stresses. That's available for the plastic capacity design according to the simplex method. It's an effective design if you choose that. For example, the program applies the normal stresses on the flanges and the shear stresses on the web. So then new features in Rwind, displaying the Rwind results directly in Rfem 6. For example, the surface pressure, as you can see in the image, the CP coefficient, and so on. More features are, we showed it already in a webinar, for example, that you can use experimental data. If you are interested in these new features, just watch this webinar. Then the third point of today, new add-ons. There's a new add-on pushover analysis. We already showed it in a webinar. You can consider the real structural behavior and seismic analysis. And it leads to an efficient design. Just watch this webinar if you want to use the pushover analysis. Then another new feature also for the dynamic analysis is the time history analysis. It's an analysis of time diagrams and accelerograms. In this webinar, if you want to watch the webinar, just click on the link, and you can see that we applied in this webinar, or we did a design for machine-induced vibrations. So then the fourth point of today, the prospects. Approximately 1 year ago, I presented a similar webinar, and we planned that features, beginning with 2023. Those are the features that I introduced, and all what is now green are already implemented. I showed the load transfer, the new add-on, pushover analysis, cloud computing, and so on. Those are already implemented. So, and in the next slide, you can see the 4 features that are still remaining. The first 4. That's also on the agenda for the future. That's why I called this headline planned features from beginning from this year. Those are the first 4 features are add-ons that we offered in Rfem 5. And we forced to implement them also in Rfem 6. What we also plan is, schedule is the design of timber frame wall assemblies. That's a typical construction type of prefabricated houses. Then the Python console will be implemented. It's a future-proof input panel, flexible to use. Then in steel joints, we schedule to implement the dimensioning and labeling tools. We already implemented the points on surface that they can be snapped, and that's a requirement for this feature. We will implement that in the future. Then you should, or it's planned that you can consider the stiffness in the global model, the real stiffness of the joint, and then the transfer to the global model will be possible. Footings are also planned. Then the partial deletion of results. For example, imagine you have got a basic reinforcement of one floor that you want to change. You don't need to calculate the other floor or to design the other floors again. That's only one example. Then moved loads, that was an add-on in Rfem 5, and we plan to implement it directly in Rfem 6. That's then available in Rfem 6, and you don't need to buy an add-on for that. Then support load transfer to free loads. That's a more flexible solution than that what we showed, that what I showed in this webinar. Then bridge combinatorics. You can create load combinations according to Eurocode for bridges or for bridge design. Then damping elements for dynamic analysis. Then pulley members will be available. Our wind results completely in Rfem, not only what I showed in the PowerPoint, also will then available the streamlines, for example. You can animate them then in Rfem and so on. Then the hinge result diagram, for example, for pushover analysis. Then the nonlinear time step analysis, that will be an extension of the time history analysis add-on. Then the scaffolding support, if an axle force depend support. Then ground linearization, it's an optional substitute of soil solid by spring supported surfaces to optimize or to decrease the calculation time. That will be an option. Then fire protection of timber surfaces. You can, or the calculation will be done using the reduced cross section. Then independent mesh, e.g. for the geotechnical analysis or solid design. Then I forgot semi-rigid diaphragms. That will be an option in building model add-on for floor elements. Then now I am concrete design. Can consider pushover hinges and the pushover properties depending on reinforcement. Then the automatic reinforcement layout for members. For the fire protection, we will implement the zone method, and then the definition of existing punching shear reinforcement. Then welds will be implemented in our section. You can define them there and also design the welds. So then shear wall design and coupling beam design, and normative design depending on material. Then enhanced plasticity design. at the moment when you do a warping torsion analysis, then there is an elastic design, and in the future it's also possible to do a plastic design in combination with the warping torsion analysis. Then we will implement new standards for steel and timber structures. For example, the standards of China, Italy, USA, South Africa, and so on. Then the wind analysis, we plan to implement also the cloud computing. Usually the wind analysis takes a lot of time sometimes, depending on the model, what you want to design. And then you can use the cloud calculation. Then we will implement Python interfaces, BricsCAD, Excel, DSTV, and SDNF. And the last planned feature what I would like to introduce here is the artificial intelligent chatbot. It will be an option on our website and in the program for 24/7 assistance. We collect all the information that you already get on our website, for example, in the FAQs or the knowledge bases or the product features. And you can enter a question and then the program or the chatbot gives you an answer. It don't replaces our normal support, of course. It's an additional option for you. For example, when you want to get information in the evening or at the weekend and so on. Okay, that should be all for the features, for the new features and the planned features. I would like to invite you to the Digital Bau in Cologne. You can secure your free ticket if you want. You can book a live demo. Just click on that link or scan that QR code. And then you get a live demo and you get a free ticket. If you don't come to Cologne, you can book your free online appointment anytime. Just click on that link. For example, for a product demonstration or something like that, just contact our sales team anytime. Okay, then I turn to the website to show you where you can find all for this webinar, dlubal.com, and under news and events, you can find the webinars. That's today's webinar. Those are the webinars for the next week. This is for the next week and those are for the next weeks. Next week, geotechnical analysis in Rfem 6, then the timber floor calculations, the FAQ webinar that I also present together with Jürgen, then the calculation of reinforced concrete slabs, and so on. Okay, I click on today's webinar. In the next days, you will get an email that there's a link implemented that leads directly to that page. Then you will find the recording here. You can already download the presentation slides here. And you can find the models here and can download them if you want to go through the webinar by yourself. Okay. That should be all from my side. Thank you for your attention. I hope we meet each other in a future webinar. Thanks to Jürgen for answering the questions. maybe a last wish when you leave the webinar. There's a small survey. You can score the webinar. Yeah, just consider that the worst score is 1 and the best score is 5. You can enter wishes for future webinars and so on, yeah, but you can also leave those fields empty if you want. Okay, then have a nice rest of the day and bye-bye.